$143 million, a top speed of Mach 2.25, and a radar signature so small it is effectively invisible. The Raptor's design requirements were drafted in 1981, at the height of the Cold War. Yet 40 years later, it remains the standard against which every modern fifth-generation fighter is measured. It exists as two different weapons in one airframe. It is a long-range sniper that destroys targets before being detected, and a high-performance brawler capable of winning the tightest dogfights. This longevity isn't a fluke. By focusing on air dominance above all other mission sets, engineers built a machine that pushed the boundaries of stealth and physics further than any aircraft that came before it. To see how this aircraft maintains its lead in an increasingly crowded sky, subscribe to the Global Warwatch Network. We break down the engineering of the world's most advanced military hardware. Despite its 62-foot length, the F-22 registers on radar like a marble, a cross-section of 0.0001 square meters. This ghost profile is achieved through edge alignment. Wings, tail, and inlets are swept at exactly 42 degrees. Radar isn't reflected back, it's deflected away. Every surface uses continuous curves to scatter remaining waves, while the access panels and weapons bays feature saw-toothed edges. These jagged cutouts ensure that even the tiny gaps in the aircraft's skin disperse radar energy in multiple directions. While other jets rely on thick layers of radar-absorbent material, or RAM, the F-22 uses these heavy coatings sparingly. By prioritizing geometric shape to manage reflections, engineers kept the jet light enough to maintain its agility. The result was the world's first fighter designed for all-aspect stealth, difficult to detect from the front, from the side, or the rear, without sacrificing the performance needed for air superiority. Providing that performance are two Pratt Whitney F119 engines, which together produce 70,000 pounds of thrust. This power allows the F-22 to supercruise, sustaining speeds of Mach 1.82 without using its afterburners. Most other fighters must burn massive amounts of fuel just to stay supersonic. The Raptor does it while maintaining its mission range. This fuel efficiency allows the F-22 to strike at Mach 2.25 and exit the area before a retaliation can be organized. It covers more distance at higher speeds than its competitors, while keeping enough fuel in the tanks for a sustained fight. The F-22 supplements that speed with agility, driven by two-dimensional thrust vectoring. The engine nozzles can pivot 20 degrees vertically, allowing the pilot to force the aircraft into maneuvers at angles of attack that would cause other jets to stall. This combination of vectored thrust and a 9G airframe makes the Raptor nearly untouchable in close quarters. During a 2006 exercise in Alaska, a single F-22 reportedly simulated taking down over 100 opposing aircraft without being hit once. Decades after the Raptor's debut, other nations have finally fielded their own fifth-generation answers to American air dominance. Russia's Su-57 Felon is highly maneuverable, but its stealth is limited. With a frontal radar cross-section of 0.5 square meters, it is roughly 5,000 times more visible to radar than the F-22. The program has also struggled with reliability. Production delays and a lack of next-generation engines have left the Russian fleet with only a handful of combat-ready airframes. China's Chengdu J-20 is a more significant threat, with over 300 units in service. It is designed as a long-range interceptor, but it uses forward canards to maintain lift at high altitudes. Those canards provide aerodynamic benefits, but they create a major stealth penalty. They reflect radar energy from the side and front, preventing the J-20 from matching the Raptor's all-aspect invisibility. While rivals have matched individual traits like production numbers or range, none have successfully integrated the F-22's specific blend of all-aspect stealth, fuel-efficient supercruise, and thrust-vectored agility. But the pursuit of this level of performance came with a cost. The F-22 is perhaps the most expensive fighter ever built, and that financial weight eventually ended its production. While the flyaway cost is $143 million, factoring in the total research and development budget brings the price to roughly $350 million per aircraft. Because the US banned the F-22 for export to protect its secrets, there was no way to share these costs with allies. This led the government to cap the fleet at just 187 operational aircraft, far below the 750 originally planned. The fleet is also notoriously difficult to maintain. Operating one Raptor costs over $80,000 per flight hour, largely due to the specialized climate-controlled environments required to protect its sensitive stealth coatings. In building a machine so optimized for combat, the Air Force created a low-density asset. Each jet is so expensive and irreplaceable that they cannot be risked in anything less than a high-end conflict. To keep these aging airframes relevant against modern threats, the Air Force is spending $11 billion on a modernization program known as Raptor 2.0. This update introduces external fuel tanks to increase range for Pacific missions and new infrared sensors for passive detection. It is a necessary shift, trading a small amount of the jet's pure stealth for the sensors and endurance needed for 21st century warfare. The F-22 Raptor is the final expression of Cold War ambition, a specialized tool for a specific mission. It will hold the line as the world's premier air superiority fighter until the next generation of air dominance arrives in the 2030s. Thanks for watching. If you enjoyed this breakdown, like the video and share it with a friend. Let us know in the comments which aircraft you want to see us cover next. We'll see you in the next one.